angles of the form a by 2, a by 3, a by 4. For example, if you have pi, pi by 2, pi by 4, pi by 6. In the same way, the fractions of all the angles are called as submultiples angle. Along with these formula, we have one important formulas, that is transformation formulas. Here we have two types. So the very important here is, if a plus b are angles of a triangle, we have the following equivalence. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in today's session, I'll be introducing to the new chapter, Trigonometry. So what are the things we are going to learn in this session is all the formulas in the chapter Trigonometry, which you will be used for all types of problems related to trigonometry. So here in this session, we will be learning all the important formulas related to trigonometric function. So look here, important points to remember. So what are the points here? If A, B, C are angles of a triangle, then angles of the form a plus b, a minus b are called compound angles. That is the sum or difference of any two angles in the form of any trigonometric function. That it may be in the form of sin a plus b or sin a minus b, cos a plus or minus b, tan a plus or minus b. Similarly, other trigonometric ratios. So they are all called as compound angles when there is equal to the sum or difference of any two angles. Next is the angles of the form 2a, 3a, 4a are called as multiple angles. For example, sin 2a, secant 3a, tan 2a. So here you can see, so when the angles are different, it is a plus b. When the angles are same, it is a plus a, 2a, a plus a plus a, 3a, a plus a plus a plus a, 4a. So there are multiples of the same angle. So to find the values of those multiple angles, again we have a certain formulas. So angles of the form 2a, 3a, 4a are called as multiple angles. Again, angles of the form a by 2, a by 3, a by 4. For example, if you have pi, pi by 2, pi by 4, pi by 6. In the same way, the fractions of all the angles are called as submultiples angle. Again, we are going to learn the formulas of the submultiple angles. So let's start learning the important formulas. For the first one, we have a compound angle formula. So let us learn and write all the formulas related to compound angles. First, let me take sine of a plus b. Sine of a plus b is given by the formula sin a cos b plus cos a sin b. This is sin a plus b. Sin a plus b is given by the formula sin a cos b plus cos a sin b. Next we will take sin a minus b. Sin a minus b is sin a cos b minus cos a sin b. So interchange the sign, you will get sin a plus b and sin a minus b. Let's see for cos a plus b. Cos a plus b is given by the formula cos a cos b minus sin a sin b. And cos a minus b is given by the formula cos a cos b plus sin a sin b. So this is how we are going to find the sum or difference of any two angles in terms of sine and cos. We have a tan a plus b also. So tan a plus b is equal to tan a plus tan b over 1 minus tan a tan b. Similarly, tan a minus b is equal to tan a minus tan B over 1 plus tan A tan B. And all other cosecant, secant and cot can be taken as the reciprocal of these function. Find the value, again convert it into secant, cosecant or cot function. So generally the knowledge of sine, cos, tan is enough to find the sum or difference of any two angles. For example, we know the standard values for the standard angles, that is 0 to 90 degree. For sine 30, cos 60, tan 45, 90, 180. We know the values. But whenever other angles are given, for example, sine 75, we doesn't know how to find sine 75. But sine 75 can be written as sine 45 plus 30 degree. Sine 45 plus 30 degree. So any angles can be represented as the sum or difference of two standard angles. So applying sine A plus B formula here, sine A plus B formula, this can be written as sine 45 cos 30 plus cos 45 sine 30. So substituting the standard values and solving, we can find the value of sine 75 degree. So therefore, the compound angles formula are necessary to find the values of certain trigonometric angles. Next, we come across multiple angle formula. As I said, multiple angles will be in the form of 2a, 3a, 4a, etc. So for your syllabus, mainly you concentrate on only two types, that is angles which contain 2a and angles which contain 3a. So therefore, let us see now what is sine 2a. Sine 2a can be written as 2 sine a cos a. And one more formula where sine 2a can be used, it can be written as 2 tan a divided by 1 plus tan square a. So these are the two formulas which are meant for sine 2a. Next we take for cos 2a. Cos 2a can be written as cos square a minus sine square a. So if you substitute cos square a, we know that sine square plus cos square is equal to 1. So if you want cos square, if you substitute 1 minus sine square there, if you substitute 1 minus sine square, you will get one more formula for this, that is 1 minus 2 sine square a. And if you replace for sine square, if you want sine square, it is 1 minus cos square. So there also you have one more formula, that is 2 cos square a minus 1. And along with this we have one more formula, that is 1 minus tan square a divided by 1 plus tan square a. So we have four formulas for the multiple angle cos 2a. So for sine 2a, it is 2 sine a cos a and 1 is 2 tan a divided by 1 plus tan square a. Cos 2a is cos square a minus sine square a, 1 minus 2 sine square a, 2 cos square a minus 1, 1 minus tan square a divided by 1 plus tan square a. Next, what is tan 2a then? Tan 2a is 2 tan a divided by 1 minus tan square a. Well, all these angles we got from the compound angles itself. I'll just show you one example. We know that tan a plus b is tan a plus tan b divided by 1 minus tan a tan b. So if you replace b as a, then it is a plus. If it is b is equal to a, then a plus b is a plus a, which is 2a here. And here it is tan a again, tan a, 2 tan a. Again here 1 minus tan a into tan a, it is tan square a. So this is how we got the multiple angles from the compound angles. So all these sine 2a, cos 2a, we got it from sine a plus b and cos a plus b itself. And all these are rearrangement based on standard identities. So when you solve this, you will get back the same function, that is cos 2a. So this is about the multiple angle 2a. Next we will look at for 3a. What is sine 3a? Sine 3a is given by the formula 3 sine a minus 4 sine cube a. This is also again obtained from sin A plus B only, where 3A is taken in the form of, using sin A plus B formula only we get, where sin A plus B is here A plus 2A, which becomes sin 3A. Again, we use the same method using sin A plus B formula. We will expand. Again, we will substitute sin 2A formula to obtain this formula. Therefore, sin 3A is equal to 3 sin A minus 4 sin cube A. Next, cos 3A is 4 cos cube A minus 3 cos A. So, this is the formula for cos 3A, that is 4 cos cube A minus 3 cos A. So, next is tan 3A. Tan 3A is 3 tan A minus tan cube A over 1 minus 3 tan square A. So, this is the formula for the multiple angle sin 3A, cos 3A and tan 3A. Again, all these formulas are obtained using the compound angles formula only. So, learn all this formula again. Next, we move on to submultiple angles. Submultiple angles, angles in terms of fraction A by 2, A by 3, A by 5, etc. So, now let us look at for submultiple angle formula. We have sin A in the form of 2 sin A by 2 cos A by 2. We know the formula sin 2A is equal to 2 sin A cos A. So, to get submultiple angle, so replace 2A with A. Then here, whatever A you have, it becomes A by 2. So, when you have 2A, it is A. Then replace it, it becomes A by 2. So, therefore, you will get this formula. Sin A is equal to 2 sin A by 2 cos A by 2. Again, we have one more formula, that is 2 tan A divided by 1 plus tan square A, where A should become now A by 2. So, therefore, it is 2 tan A by 2 divided by 1 plus tan square A by 2. Next, we can write cos A in the form of cos square A by 2 minus sin square A by 2, or 2 cos square A by 2 minus 1, or 1 minus 2 sin square A by 2, or 1 minus tan square A by 2 whole divided by 1 plus tan square A by 2. So, next we have tan A. It is 2 tan A by 2 divided by 1 minus tan square A by 2. So, this is the formula to find the submultiple angles of sine, cos and tan function, where other function can be took as a reciprocal of these functions. Along with these formula, we have one important formulas, that is transformation formulas. Here we have two types. So, the sum of the function to the product of the function and product of the function to the sum of the function. First, let us see sum or difference to product. So, we are converting the sum or difference of functions to the product of function. So, first is sin C plus sin D. So, whenever you get the angle in this form, sin C plus sin D, for example, sin 15 plus sin 40, like that, how to write this in the form of a product and find the value. So, sin C plus sin D is 2 sin C plus D by 2 into cos C minus D by 2. So, this is the transformation of the sum of sine function into product of sine and cos. Again, these all are derived from the compound angle itself, but the derivation is not necessary. Just learn only the formulas. Next, what happens if it is sin C minus sin D? It is given by 2 cos C plus D by 2 sin C minus D by 2. Next is cos C plus cos D. Cos C plus cos D can be written in the form of 2 cos C plus D by 2 into cos C minus D by 2. Next, we will look it for cos C minus cos D. Cos C minus cos D is minus 2 sine C plus D by 2 sine C minus D by 2. So here we are converting the difference into the product of two functions. So these are the four important formulas of transformation from sum or difference to product. Next, we will see product to sum or difference. So here we are transforming the product of any two trigonometric function into sum or difference of trigonometric functions. Next, we have sin A cos B. Sin A cos B can be written as half into sin of A plus B minus sin of A minus B. You can verify this formula. Take sin A plus B, subtract from sin A minus B, you will get 2 sin A cos B. So therefore sin A cos B, if you need, shift 2 to the denominator. Again we have sin A and sin B. If you want sin A and sin B, then you should add and subtract cos A plus B, cos A minus B. So therefore that is minus half of cos A plus B minus cos A minus B. Next we will take cos A sin B. So cos A sin B is half of sum of sin A plus B to sin A minus B. Next we will take cos A cos B. Cos A cos B is half of sum of cos A plus B and cos A minus B. When you add these compound angles, you will get back your left hand side. So 2 is written in the denominator. So along with all those compound angles, multiple angles, sub-multiple angles and transformation formula, we have certain important results which has to be remembered while solving the problem. So the very important here is, if A plus B are angles of a triangle, we have the following equivalents. What are the equivalents? If A, B and C are the angles of a triangle, then the sum of the angles is 180 degree. So if I need A plus B, then it is 180 degree minus C. So 180 degree minus C means it lies in the second quadrant. It lies in the second quadrant. Now apply sine, cos, tan for this function. What is sine of A plus B? So here sine of A plus B is nothing but sine 180 degree minus C. Apply sine functions on both sides. So sine 180 minus C. So in the second quadrant, sine is positive. So therefore, this is equal to sine C. So what I can conclude? Sine A plus B is same as sine C. This is possible only if A, B, C are angles of a triangle. Then what is cos A plus B? Cos A plus B is nothing but cos 180 minus C. So in the second quadrant, cos is negative. So therefore it is minus cos C. So therefore cos of A plus B is nothing but minus cos C. Next apply tan A plus B to the equation. Then it becomes tan 180 minus C. Again in the second quadrant, tan is negative. So therefore it is minus tan C. So therefore tan of A plus B can be written as minus tan C. Now this is for the angles in the form of A, B, C is equal to 180 degree. Suppose if the angles are in this form, that is half angle formula, A by 2 plus B by 2 plus C by 2 is equal to 90 degree. Then what is the formation of sine cos? So A by 2 plus B by 2 can be written as 90 minus C by 2. This can be written as A plus B by 2 is equal to 90 minus c by 2. If you take this some equation, apply sine on both sides. So then it is sine of a plus b by 2 is nothing but sine 90 minus theta formation, that is sine 90 minus c by 2, which becomes cos c by 2. So therefore, sine a plus b by 2 can be replaced by cos c by 2. Again cos a plus b by 2. So cos a plus b by 2 means on your right hand side it is cos 90 minus c by 2, which can be written as sine c by 2, because sine 90 minus theta is cos, cos 90 minus theta is sine. Again tan a plus b by 2. So tan a plus b, if you apply on this side, it is tan 90 minus c by 2, which is nothing but your cot function c by 2. So these are the transformation whenever A, B, C are angles of triangle. Next, along with this, we have few more results which is obtained from multiple angles. So we know that cos 2A is nothing but cos square A minus sine square A, or it can be written as 2 cos square A minus 1, or it is 1 minus 2 sine square A. So based on these results, we have the formulas for sine square A and cos square A. So what if I need sine square A? So here cos 2A, if you shift this, it becomes minus 1, which is equal to minus 2 sine square A. If you want to remove minus on both sides, then it is 1 minus cos 2A is equal to 2 sine square A, or if you need sine square A, shift this by 2. So the sine square A formula is 1 minus cos 2A divided by 2. Similarly, for cos square A, take this function. 2 cos square A minus 1 is cos 2A. So shift 1, it becomes 1 plus cos 2A divided by 2. So this is for the angles related to 2A. Again, if you want to change it to submultiple angle, so here A becomes A by 2, and wherever you have 2A, it becomes only A. So cos A divided by 2, and here cos square A by 2 can be written as 1 plus cos A divided by 2. So this is the formula we can take. So 1 minus cos 2A by 2 is nothing but sine square A. Cos square A is 1 plus cos 2A by 2. Again, it's submultiple angles which take the same form, but A by 2, 2A by A. So we have learnt all those formulas related to compound angles, multiple angles, submultiple angles, transformation, angles related to triangles, and some important results from the multiple angles. All these formula are very necessary to solve the problems. So we'll meet you in the next session related to the problems on trigonometric angles. Until then, keep watching, keep learning and keep exploring. Thank you.